Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. How can we write a rule for a geometric sequence? Well, first of all, what is a geometric sequence? It's just a sequence or a list of numbers that we get from one number to the next by multiplying by a common ratio. So we can write an equation for the nth term of a geometric sequence, and it would look like this. It tells us the nth term of a geometric sequence with first term a sub 1, and common ratio r is given by a sub n is equal to a sub 1 times r to the n minus 1. So we're going to look at 4 examples today. The first 2 are going to be pretty straightforward. They're giving us a sequence, and we're just going to plug in our information, the first term and the common ratio, and write our nth term equation. But if you notice on number 3, they're giving us one term of the sequence and the common ratio. So that one will be a little bit more hands-on, a little bit difficult. But number 4, we're not given the common ratio. We're just given 2 terms in the sequence. So we're going to have to really dig deep to figure out the equation for number 4. So make sure you stick around to number 4. All right, number 1, we have 10, 20, 40, and 80. So the first thing we want to do is just write down our equation. So a sub n equals a sub 1 times r to the n minus 1. And essentially, we just need to identify what the first term is and what we are multiplying by to get to our next term. So obviously, our first term here would be 10. So we're going to plug in a 10 right there. And notice that we are multiplying by 2 to get to our next term. So we're going to plug in a 2 right there and raise it to the n minus 1. Okay. All right, number 2, we have 6, 2, 2/3, and 2/9. So it looks like we are dividing by 3, but let's remember we want to write this in terms of what we're multiplying by. So we can see our first term is 6. So we have our equation here, and we're going to plug in 6 for a sub 1. And now we are actually multiplying by 1/3 as we go. And so we're going to plug in 1/3 for our common ratio. All right, so got the 2 easy ones out of the way. So now let's dive in here to 3 and 4. So for number 3, we have the 5th term of the sequence is 32, and our common ratio is 2/3. So once again, let's just start with our nth term equation. A sub n equals a sub 1 times r to the n minus 1. And let's plug in the information we have. Well, we know that when n is 5, a sub n, or a sub 5, is 32. So if I'm going to plug in a sub 5, I could plug in 32 over here. I don't know my first term. I know my common ratio is 2/3. And what term is 32? It is my 5th term. So we plugged in 5 for n, and we plugged in 32 for a sub n. So now we just need to simplify. So 32 is equal to a sub 1 times 2/3, and 5 minus 1 would be to the 4th power. Now let's distribute that power. So now we have a sub 1 times, and this would be 16 over 81. Okay. Now to solve for a sub 1, we're just going to multiply both sides by the reciprocal, so 81 over 16. And that's going to give us a sub 1 is equal to 162 once we do 32 times 81 and then divide that by 16. Okay, so we're not done yet. We have to take that information. We know our common ratio. Now we know our first term, so now we can write our nth term equation. So a sub n equals 162 times 2/3 to the n minus 1. All right, now for the last example, number 4, we are just given now 2 terms of the sequence. So now we have to figure out what's the first term and what is the common ratio. So we have our nth term, a sub n equals a sub 1 times r to the n minus 1. Now let's write 2 equations here with these 2 terms that we're given. So let's write the first one would be 20 is equal to a sub 1 times r to the 3 minus 1. And then negative 160 would be equal to a sub 1 times r to the 6 minus 1. Okay, well now we can simplify these just a little bit by subtracting those exponents. So 20 is equal to a sub 1 times r squared, and negative 160 is equal to a sub 1 times r to the 5th. So now what I'm going to do is I'm going to take my first equation there, 20 is equal to a sub 1 times r squared, and actually solve that for a sub 1. Essentially, I'm solving like a system of equations by substitution. So I'm going to take this equation down here, and I'm going to solve it for a sub 1, and then take that expression and plug it in for a sub 1 into my other equation. So if I have 20 is equal to a sub 1 times r squared, let's divide both sides by r squared. So now we have a sub 1 is equal to 20 over r squared. And I'm going to take this expression right here, and I'm going to plug it in to a sub 1 into my other equation. So now I have negative 160 is equal to 20 over r squared times r to the fifth. Okay, so now we have r to the fifth and r squared. Those are exponents, or those are common bases. They are like bases, and we have exponents, right? So we can use an exponent rule there. So this would be like 20r to the fifth divided by r squared. So we could subtract 5 and 2. And this is going to end up giving us negative 160 is equal to 20r cubed. Okay, so now let's divide both sides by 20 and see if we can solve for our common ratio. So now we're going to get negative 8 is equal to r cubed. And now let's take the cube root of both sides. So we're going to get negative 2 is equal to r. So let's put a little star by that. We know what our common ratio is now. Well, now that we know our common ratio, we can take that and plug it into either one of our original equations. Let's just plug it into r squared up here for 20 is equal to a sub 1 times r squared. So now we have 20 is equal to a sub 1 times negative 2 squared. So negative 2 squared would be 4. And now let's divide both sides by 4. So now we figured out that our first term is 5. And now the two pieces of information that we need have a star by them. Our first term is 5, and our common ratio is negative 2. So we'll come back up here to the top and say a sub n is equal to 5, and this would be times negative 2 to the n minus 1. All right, and that's how we can write a rule for a geometric sequence.